In this video, I will guide you step by step on how to create an animated book slider using Three.js and React Three Fiber. You will be able to customize it and reuse it in your own projects to make them more impressive. In addition to learning how to create this slider from scratch, this video includes tons of useful explanations about geometries, skinned meshes, skeletons and bones that you will benefit from throughout all your Three.js projects. Before diving into the video tutorial, if you are new to 3D web development or want to build a solid foundation, consider exploring my course, React Three Fiber, the ultimate guide to 3D web development, a project-based course with everything you need to know and more to start creating professional 3D web experiences. Let's start by cloning the starter pack that I prepared for you. Link is in the description. Copy, in a terminal, run git clone and paste the URL. I will enter manually where I want to put it. Enter. Once it's cloned, you can open the folder with File, Open Folder, then yarn to install the dependencies, and yarn dev to start the development server. Let's open the link to see what we have. We have a ready-to-use React Three Fiber template with a background text animation and all the pages that are defined that we can click and it will switch the page. And on top of that, we will create our book and animate it. Let's start by removing the slider animation. We'll put it back at the end of the video. So here it's all the pictures that we will use. Then the logic to change page. Okay, but let's disable our slider. So here it is. We can add hidden. Okay, we will start from there. Let's create a component that we will name book. Inside components, new file, book.jsx. Then we export our book. It will take some basic props, so we will be able to positionate it from the parent. And we will return a group that takes the props. And our book is composed of all the pages we have. So we have an array named pages that is defined in the UI. Let's have a look at it. It's an array of items containing a front, it's a path to an image, and a back. Here it's using all the different images in my pictures array. And for the front page, it has book cover. And for the last one, it has book back. All those images are provided in the repository inside public. Textures, if you look at book back, it's just this gradient. Book cover, it adds my logo, Wawa Sensei. Of course, you can change it and make it yours. And all the other ones are pictures that I took when I was on vacation. To make it more optimized, you can use Squoosh.app to reduce the file size of your image without losing quality. Alright, so we know what our page array is composed of. So we can loop through it. .map. And for each page, we will render a page component that we will create. So let's say for each page, we have the page data and the number of the page, which is here the index. So we can add the key is equal to the index. The number of the page is also the index. And we can pass all the rest of the page data. Let's create our page component. I decided to make it in the book, but if you prefer, you can create it in a separate file. Const page. Like we did, we will have the number. We know we have front and back, but we won't use it at the very beginning. And also rest of the props. Let's return a group that use all the props. So if we want to change the position later, for example, and inside we can add just a small box to see if it's working. With a mesh basic material red, let's scale it down. And for later, let's have a reference on our group. Let's name it group. Const group is equal to useRef. Currently, we can see nothing on the right. It's because we need to add our book to our scene. So the main things are happening in the experience component. What we can do is add our book here. And here we can see we have one mesh because they are all at the same position. Let's say, for example, position x is equal to index multiplied by 0.1. You can see all of them, so maybe 15, so you can see the space. So here are all our pages. To make it simpler to design our page, let's use only one page for the beginning. What we can do is index is equal to 0. Then we render the page. If not, we render null. So we only render the first page. Now the interesting part. What we will need to really display a page. Maybe you were thinking that we could use a plane, but because we want to have a 3D structure of a book, we can't use a plane. Here, if I load the final project, you can see our book is in 3D. If I open a page, you can see here in the back that the book is really in 3D and it has depth. So instead of a plane, what we will render is a thin box. We will create manually with Three.js. So let's head to Three.js documentation and BoxGeometry. Then you can have a look at how it works. You can define a width, a height. Let's say it's higher than its width. You can change the depth. So to look like a page, we need a thin depth. And because we will want to bend it, we will need to have a lot of segments to be able to shape it. So we need to adjust the number of width and height segments to have a lot of places to bend it using bones. We'll talk about it later. And the depth segment. Then you have a code example on how it works here. To create our geometry, we need to define variables to fill those holes here. So we have the page width, the page height. I chose to have a 4/3 aspect ratio. The page depth, I chose a very thin one. Then the number of segments and the width for each segment. It will ease our calculation later, but we could do it at runtime. So it's page width divided by the number of page segments. Because our page geometry will be the same for each pages, we can define it on top of the component to avoid to create new instances while just one is perfect. So page geometry is equal to new box geometry of page width, page height, page depth, the number of segments, 2 for the depth segment, and don't forget to import box geometry from 3. Oh, I think here the 2 is for the height segment. We only need to define a high number of width segments. Let's try our geometry. Here we can use a primitive. Object is page geometry, and we attach it to the geometry of our mesh. And here we have one page. But because we only have one material, only one face is rendered, so we can see the depth. Because we want to be able to bend our page, we won't be using a mesh. Instead, we will be using a skinned mesh. The only difference between a mesh and a skin mesh is that the skin mesh, it has a skeleton with bones that can be used to animate the vertices of the geometry, which means you have one root bone. If you modify it, it will move the entire mesh here, the entire geometry. But if you choose another bone, for example, the second one, you can see it's bending the bone and it's creating more interesting things you couldn't do by just using a mesh. Once again, there is a code sample to explain us how to do. First, we will need to add the skin weight for each vertices. What it means is how each bone will impact each vertex. For example, the one on the bottom will be affected by the bone 0, while if you take the one on the top, they will be impacted by the bones from the top and they won't have any influence on the one below. This is generally what you do in Blender when you are using the weight paint feature when you have an armature and bones. For example, I'm on the first bone. I can say here I want to add some weight paint. So this bone will affect here this part of the mesh, and the further away it won't impact it at all. While if I take this one, maybe I could do the opposite. This one will impact this part of the mesh, those vertices here, but not the one on the left part. To achieve this programmatically and not using Blender, there is a sample of code that maybe looks complicated, but it is not, and it will highlight a lot of things that maybe you were using when you were using animations, but didn't understand in depth. Maybe you will have that aha moment. First of all, to make things simpler, I will translate our geometry to not be centered, but to be at the left. So I will push all the geometry from half, so it will start on the left here. Now you can see it was pushed and it's at the 0 position. Let's do it. First, we need to get all the positions from our geometry, which are located in the attribute position. Then we declare a vertex to not instantiate one inside the loop. Then we create an array with the indexes of our skins, which are the bones, and the associated weights for those indexes. So we loop through all the positions. So it's for each vertex. Then we copy the position from the attribute inside the vertex variable. We need to get the x position. Then to know which bone will be affected, we will be using the floor value between x, which is our current position, divided by the segment width. So if we are near 0, it will use the first bone, but if we are further away, it will use the lastest bone. Then we calculate the skin weight, so the intensity that this bone is impacting our vertices. It's a value between 1 and 0. 1 is it impacted completely, and 0, it doesn't impact it at all. And then inside our skin indexes and skin weight array, we push it. So currently we push 4 values. So the first one is the first bone that has an impact on our vertex. The second one is the second bone that has an impact, and you can put up to 4 bones on a vertex, but we don't use the 2 last one. We only use 2 bones per vertex. In the skin indexes, it's the index of the bones, and then in skin weight, it's the impact of the bone. Then we need to attach those attributes to our geometry. So for the skin index, we create a uint16 buffer attribute. We can put 4 bones that will have an impact on our vertices. And we create another one, skin weight. It's a float 32 because it's a value between 0 and 1. And we do the same, but with the weight. Now let's create our skin mesh. And it's not something that we will share between all the pages. It is unique for each page because each page will have its bones and animations. So inside our page, we will create it inside a use memo. To create our skin mesh, we need the geometry, the material, and to create a skeleton that will contain our bones, and to add our root bone to our mesh, and to bind the skeleton to the mesh. Let's do it. First, we need to create our bones. So we create an array. We'll have as many bones as we have segments on our page. For each segment, we will create a bone with new bone. Then we will push it to our bones array. If it is equal to 0, the position of the bone on the x-axis will be equal to 0. If not, it will be equal to the segment width, to offset it of the size of a segment. Then, if it's not the first bone, we will attach our new bone to the previous bone, so it's a child of it. And then we create our skeleton that contains the array of bone we just did. It's pretty simple. Then for our skin mesh, we will need some materials. We will create them inside page materials that we will share between everything, so we'll do it just after. Then we create our skin mesh with the page geometry and the materials. Then on our mesh, we can do a lot of things. Cast shadow, receive shadow, frustum called false. So if we are close to it because we bend it, we will still be able to see our book. Then we add the root bone to our mesh and we bind the skeleton to our skin mesh. And we return our skin mesh so we'll be able to use it declaratively. First, be sure that you have made all the import, control space, and do all the required import. Maybe we will need a reference on a skin mesh later, so let's create it. And let's create our page materials. We can do it on top of our page. Our page materials, it's an array of 6 materials. Why? Because our box geometry has 6 faces and we have 1 material per face. The last ones are the front and back face. We will see it just after when we will render our skin mesh. So to render our skin mesh, we need to go here and replace the mesh that we are currently displaying. Instead, we will use a primitive with the object, the manual skin mesh that we created and a reference to it. Let's save. And here is what we have. You can see we have our thin page. So here it's very thin, but you can see it's the dark color. That is, where is it? Here. This is the 111. We have the white color a bit everywhere. We have the pink. You can see we have one color per face. But the most interesting part is the fact we created a skin mesh with bone. So let's visualize it. Let's go right after our mesh declaration, and we can use helper of our skin mesh ref we created and the skeleton helper from 3 and save. Now you can see on the right what appeared are the different bones. They are very small because we have a lot of bones. Maybe I will reduce the number of bones we have, maybe 5. And you can see we have 5 long bones containing our page. Let's try to change one of the bones to see how it works. Let's go inside our component, inside a use frame. We can access our bones with skinmeshref.current.skeleton.bones. To be sure we have it initialized, let's be sure that we have a current value. And bones of, let's say, 2 dot rotation dot y is equal to deg to rad of 20. And you can see it's bending our page a little bit of 20 degree. Let's do it a bit more, 40. And our page is bent. If we try to go further, let's say on the 4th bones, it will go the opposite way. And it's bending our page. So now we have the control to impact how our page is distorted. Let's say we want to impact it a bit also on the x-axis of 10 degrees. You can see now we just have to animate it to give life to our book. Fine, so first let's remove the manual things we are doing here and let's restore the number of page segments we have. I think I will be using 30. And we can also disable the helper. We know that our skin mesh is working. Before focusing on the animation of the pages, maybe we should display the content of the different pages. So here, when we created our page materials, we won't need the 2 last ones. We will create them for each page. Let's find our materials here. And instead of using page materials, we'll be using page materials and add 2 other ones that we will create. We will add one mesh standard material that will use a white color, but that will also use the picture that we will load from the front image. Then if the number is 0, we'll be using a roughness map to create a nice visual effect with the lights. If not, we will set the roughness to 0.1. So it's like on a non-matte paper, on a glossy paper. If you want a matte effect, use 1 or a value near 1. Then we do the same for the back. So mesh standard material, white, you will use the picture 2, which will be the back image. Then if it is the last one, we will use the roughness map that we will load later, or 0.1. Let's declare our texture from the front and back values. So we create an array. We'll have picture, that will be front, and picture 2, that will be back, and picture roughness in case we are the first or last one. So we use texture of textures/front.jpg, then same for back, and we check that we are the first or last one, and in that case we load the picture roughness image, and if it's the case we load it, otherwise we don't. If we save, this is what we have. You can see that on the front image you have that Wawa sensei that reacts to light as if our paper had some depth. Let me show you the texture. So it's roughness here. So if it's white, it means it's a value of 1, so it's not glossy. But if it's black, it's a value near 0. And if it's pure black, it's 0. Then it will be very glossy. So only the parts that are drawn with Wawa Sensei are very glossy, which creates this nice light reflection effect. Currently, we are only displaying the first page. Let's have a look at the back. And we can see we have the first picture. but the color isn't perfect compared to what I'm using. What I need is to change the color space that it's being used. So color space is equal to picture2, so it will change both at the same time, to sRGB color space. And I hit save. Now you can see that we have the nice gradients, and here it's more looking like at the actual picture. And we still have the nice light effect, a very glossy paper. One last thing, to have the loader at the beginning that preload everything, we need to use pages for each and use texture preload for all the different texture we'll be using. If I reload, it will be slower, but all the image will be loaded instantly. Before animating all the pages, first we need to render all the pages. So let's head back to our book and remove that condition and render all the different images. Here is what we have. It's not ideal. They are all fighting on the Z position. To position them correctly, we need to know on which page we currently are. So here we will add a new one, which is page is equal to page. And we have a page variable, page, that is equal to use atom of page atom. And it is something defined in the UI here that change when we press the different button. It will change the page value, so we know on which page we are. Now on our page, we have this new prop that is named page, which is the number of the current opened page. And on our primitive, we'll adjust the position of the page. Position Z is equal to minus number multiplied by page depth plus page multiplied by page depth. Let's save. Now they are not fighting anymore on the Z-axis, but let's remove the X position we made at the beginning. And we have a book. Currently it's closed, but it's starting to look like something. Here is the best moment. We will start to animate our page rotations to open our book and make it look like natural. Most of it will happen inside our use frame here. First of all, our page is in front of us with the rotation of 0. Our target rotation will be equal to either our page is open. If it's the case, it will be minus math.pi divided by 2. If it's not, it will be the opposite 90 degrees. But we are missing to know if our page is opened or not. We don't want to compute it in the page, but in the parent. So opened, and inside the book here, we'll add an opened. It's equal to page, so our current page is over indexed. If it is, it's open. If not, it's not. So let's try it just to see if it's working. Bounds of 0.rotation.y is equal to target rotation. Let's save. Here they are all fighting. We need to rotate, but if we turn the page, we can see some are on the left and some are on the right. To have the book in front of us naturally, we can rotate the book. So if we reload, it's directly in front of us and we can turn the page. But we need to adjust the rotation so that the pages are not colliding. To do so, we can increase the target rotation by the number of our page multiplied by a constant. And here, it's going way better. So you can see we have spaces here. But if it's closed, we still have spaces and we don't want it. Unless it's the effect you want. But me, I want to keep it closed normally. So we'll do it only if our book is not closed. And again, we will need that information on our page component, book closed, and on the book itself, book closed is equal to page is equal to 0, or page is equal to page.length. It's not perfect when it's closed right now, but we will adjust it later. But once it's open, it's nice. Currently, we are assigning the rotation directly, but instead we could lerp the value mathutils.lerp of the current rotation.y to the target rotation. And for the constant, let's declare a variable we will name lerp factor. Let's declare our constant with the other one, for example, page width. On top of it, our lerp factor. Let's see what we have. When we change the pages, we have a transition, but it's way too quick and it's linear. Instead of having a linear curve and have a easing curve, we can use the math library. To install it, yarn add math with 2a, and we will change lerp factor with easing factor to control the speed of the easing and the value to 0.5. And we replace our lerp with easing from math library dot damp angle, and it's using the object, so it's bones rotation, the key, it's y, the target rotation, the easing factor, and also the delta between each frame. So we name it delta, and we get it from our use frame. And because the function is already editing the value of the y on our object, we don't have to define the value like this. Let's try it. And we have a way smoother transition between pages. But we don't want to apply it only to the root bone, but to curve the different bones. Because we have access to all the bones, we will loop through all of them and apply a rotation to each bone to create the nice curve we want. So we will declare a target, which will be equal to, if I is equal to 0, our target, it won't be a bone, it will be the group here, the container of our page. It is because we change the z position of our page, and because we want it to be offsetted to the rotation, we want to rotate the parent, then to apply the position z. And then we will rotate all the subbones. So here it will be group.current. If not, it will be bones of I. And we also need to replace here its target.rotation, so we will impact all bones. If I save, it will roll because we are applying way too much rotation. We rotate each bone with the same intensity than we did for the first one. We need to smooth out to create the curve. Let's use GraphToy to create a function to impact each bone with the right amount of strength. Let's say x here, it's the value of our bone. So we have value between 0, 1, 2 until 30, because we know we have 30 bones. And to create a curve, we can use functions to change the shape of the value of x based on its value. So we can use, for example, sin of x. Here what it does is the more we advance through our bone, the more intensity we will have, and then it will go back below. So it will create a curve. For the inside curve of our page, what I found good was multiplied by 0.2. So let's see, we have a slow curve that will be good for the shape of our page. But I don't want to start at 0. So what I do is I add 0.25. So at the first bone, I will have a small rotation that will increase smoothly. To apply it, I create a variable named inside curve intensity. If my bone is below 8, I want to apply that inside curve. So I use the function I prepared, math.sin of I, which is the number of our bone, multiplied by 0.2 plus 0.25. If it's not, I don't want to have the inside curve, so it will be 0. Then we will compute the rotation angle for this bone. So it will be named rotation angle. It will be equal to inside curve strength, a constant we will define, that we multiplied by the curve intensity for this specific bone, multiplied by the target rotation, that is similar for all our bones. Let's go near the easing factor and declare our inside curve strength. Now we have this calculated. Instead of rotating with the target rotation, we use the rotation angle that is calculated for each bone. We save, and you can see we have a nice curve at the beginning that look like what we had here. We have more and more intensity of our based on our bone. Let's try to turn the page. And you can see it's bending one to another nicely. Perfect. This is not yet finished, but you have the main idea. Of course, it's made of trial and error, so you can play with the different variables to see how it's impacting the curve. You can change where you're starting from, if you want a huge curve here, or the one that I was using, and also the curve strength, which is defined here if you want more, but it will go way back, or a lower value, so it will be barely opened. Let's set it back to what I was using. And by using the same principle, we will do an outside curve strength and a turning curve strength while we are turning. Let's go back to our inside curve strength, and we will need to create the outside curve intensity. What we wanted to do is, the further we go away, we have a nice shape of a page. Here it's too flat. So instead of using sin, we'll do with the opposite, we'll be using cos. So we can have this shape here going down and up, multiplied by 0.3 and 0.09. It's what, and 0.9. It's what I found will work good for me. But of course, you can adjust it here or in your code. If I is over 8 or equal, we'll be using my new formula. If not, we don't impact it at all. And our rotation angle will be equal to this minus the outside curve strength multiplied by the intensity multiplied by the target rotation. We can save. And now we can see we have a new outside curve, which really looks like an open book. Nice. Before adding a last effect when we are turning the page, we have an issue if we close the book. Here all the pages are fighting because our pages are still bent while the book is closed. We need to adjust our rotational angle. So if book closed, and if I is equal to 0, then rotation angle will be equal to target rotation. So it will be aligned on the good side. If not, rotation angle will be equal to 0 for all the other bones. Fine, when we save, you can see it's correct. And when we open it, it's blending into the nice shape. If I try to go to the last page, it's smoothly going back to the neutral shape. Let's add a nice animation when we are turning the page. Currently, it's not very natural, even if the effect is already nice. We can add an extra curve while it's turning to make it like if it's someone holding the page. To do this, we will need two variables. One, turn that, where we will save the date when we change if it's opened or not for this specific page. And last opened to check if at the last frame it was opened or not. And with that, we'll be able to know when we change the turn that date. Now let's use it inside our use frame. Go below, and here, if it's different, the value between open and last open, it means we just change the value. So we can save turn@current is equal to new date. I use the plus sign to get the timestamp value. And then we store the last value of opened. I want the effect to last 400 milliseconds. What I do is I'm using the new date minus turn@current divided by 400. This way, I'm sure I have either 0 or 400. By dividing it by 400, I have a value between 0 and 1 to know if I'm starting the transition or ending it. But again, it will be linear. I will have a value going from 0 to 1 directly. To have a smooth curve, I will need to use sin of x, but because I have value between 0 and 1, and I want it to go up, I will multiply x by math.pi. So this way, when the animation starts, it will go from not folding to entirely folding halfway of the animation. And when it reaches 1, which is the end, it will go back to 0. So let's apply it to our value here. Then, like we did for the inside curve and outside curve intensity, we will do the same for turning intensity, which is the one we are applying while we are turning. I'm using this function. Of course, you can play with the value to see how it impacts it. Then to compute our final rotation angle, we have the inside curve, the outside, and we will add this time the turning curve strength with the turning intensity with the target rotation. We didn't define our turning curve strength, so let's do it. Inside curve strength. Oh, I already did it earlier, so perfect. Let's try it. You can see that when it's turning, it's bending inside before going back to the normal position. Let's add another effect. Instead of rotating the y-axis, we will also rotate the x-axis to a bit bend the page when it's turning. First, we need the fold rotation angle. It will be equal either to 1 or to -1, because math.sign return -1 if target rotation is below 0, and 1 if it's over. We don't do it if our book is closed. And like we did for the others, we create a fold intensity only when the bone is over 8. We create a curve to impact the bones. If not, we don't. And we ease our rotation only on the x-axis. With fold rotation angle, we calculated here, and our fold intensity. We will need an easing factor fold constant. Easing factor, and a second one for the fold. A good value I found was 0.3. Let's try it. We change the page, and you can see how it's bending here and add that nice natural effect when you're turning a book page. To make it better, when we are turning multiple pages at once, currently it's turning all of them with the same speed, and they are not so good looking. To adjust it, we can change the logic inside our book. We create a delayed page with a state. It will be using the page, but it will delay based on the current page and the difference to the last page that was opened. To do it easily, we create a use effect with the page, so when the page value change, and we create a timeout. So if we rechange the page, we can cancel the previous one. And then inside a goToPage function, we'll call setDelayedPage, and we will have access to the latest delayed page value. So if our page is equal to the delayed page, we just return it because we didn't change the page. If not, we'll have a timeout that we will call goToPage. And the delay to call this timeout is either we have a difference of 2 pages. If so, we will do it quickly with 50 milliseconds. If the pages are below a difference of 2, we will make it slower with 150. So the latest page will have more space between them, which results in this extra delay. And then if page is over, we increase of 1. So we'll do 50 by 50. If not, we go delayed page -1. So we don't change 10 pages at a time, but -1, -1, -1 with a delay of 50 or 150. Then we call goToPage in our use effect, and we return the clear timeout. And to use this delay page, we need to change the variable here. Delayed page. Is it open? We are using delayed page. And if the book is closed, it's also based on delayed page. Perfect, let's try it. So if I go to page 1, nothing changed. But if I open directly page 5, you can see we have that nice transition. Perfect, we have the book transition animation, but we need to add a final touch. So when we click on a page and when we hover a page, we want to highlight it and to turn the page. So let's head to our group, which represent the page here, and we will add some events. We will have on pointer enter, so when our cursor is on a page, we'll stop the propagation because we only want the first one that hit our ray. If not, all the page will be impacted. Then we set highlighted to true. Then when we leave, we do the same but to false. And when we click, we also stop the propagation and we change the page to this one and set highlighted to false. Let's create our highlighted state. So here, highlighted, set highlighted with a use state. And to have a cursor that change, we'll use cursor hook from dry, which will change our cursor from normal to pointer when we will have the highlighted value to true. Now let's try it. You can see our cursor is now highlighted. And if we try to click on the page, it's not working. It's because we didn't declare the set page. To get access to it, we can do const underscore and set page is equal to use atom of page atom. Perfect. Now, if we click on a page, it's working perfectly. To add a better effect when we are hover, we can change the emissive color of the page. First, let's go to our white color and let's create an emissive color. So we don't declare one per page, it's more performance efficient. New color of orange, and where we create our materials. So here it is. We'll add emissive. It will be emissive color, and emissive intensity will be 0 by default. It's not highlighted. We do it on both. Then inside the use frame, we will change the emissive intensity if we are highlighted or not. Emissive intensity is equal to, if we are highlighted, 0.22 or 0. Then on our skin mesh, on the fourth material, and also on the fifth, because the front and the back materials, we will lerp the value of the emissive intensity with the current one to emissive intensity and 0.1. Let's try it. If we hover the page, you can see it's becoming orange. And when we are not, it's fading back to its normal value. Perfect. Time to add the final touch. First, our rotation is not perfect. If we reload, it's facing us. Instead, we prefer it to be like on the table. So it happens in the experience, we have our book. We can wrap it in a float component to add some sort of movement. And we can rotate it a bit and add some parameters to change the intensity of the float effect. Let's save. Let's reload so we don't have my camera rotation. And here it's a bit bent and you have that nice floating effect. And now the light is not too much impacting our book. It was because it was thought that it will be rotated like that. Now inside the UI, we can remove the hidden and we have the nice effect behind our book. Of course, if you want to change the text, it's an effect that requires you to have the components doubled. So you have it once and twice. So if you want to change the text, change it one time here, and a second time, copy paste the whole component so you have the same values. And to make it perfect, let's add a use effect when the page change to play some audio. Thank you for watching. I hope you enjoyed this video. If it's the case, please hit the like button to make it more visible to other creative developers. Don't forget to subscribe to not miss the upcoming video tutorials. If you want to continue your learning journey, I recommend you watch this video, available here.